In this video, we'll write the Lewis structure for HAsO. So I'm not really familiar with this compound, but we can still draw the Lewis structure. Let's count the valence electrons up. Hydrogen, group 1, 1 valence electron. Arsenic is in group 15, sometimes called 5A. It'll have 5 valence electrons. Oxygen, group 16, 6 valence electrons. So we have a total of 12 valence electrons for the HAsO Lewis structure. We'll put the least electronegative element in the center, and hydrogen, it always goes on the outside of Lewis structures. So we have our As, put our H over here, and then we have our oxygen. We have 12 valence electrons. Let's start by putting a pair of electrons between atoms, and that's going to form our chemical bond. Then let's complete the octet on the oxygen atom here. At this point, we'll have used 10, so we'll only have 2 more. And we'll put those 2 on the central arsenic there. So we have a complete octet for oxygen. It has 8. Hydrogen, that has 2, but it only needs 2. But the arsenic here in the center, that has 6. So that's a bit of a problem. Let's take these 2 here and move them to the center and create a double bond. And when we do that, we have 8 still for the oxygen, but now the arsenic here, that has 8 as well. So this is the Lewis structure for HAsO. If you check the formal charges, they're all 0, so that makes sense. And then if you looked at the molecular geometry, it looks like it's going to be linear. But because we have this lone pair up here, we're actually going to have a bent molecular geometry. If you use the AXE notation, where A is the central atom, that's the arsenic, X, number of atoms bonded to it, 2, E, the lone pairs, we have the 1 lone pair here. So this ends up being what we call a bent molecular geometry. This is Dr. B with the Lewis structure and the molecular geometry for HAsO. Thanks for watching.